Okay, all right. So Alhamdulillah, we have finally wrap up topic 4. Okay, however, we have several checkpoints that we haven't managed to discuss last week. Okay, so we are going to do that first, and then we will continue straight away to our topic 5. Okay, the last topic for this semester, which is topic 5. Okay, all right. So I hope everybody has completed this checkpoint. Okay, let's go through the question first. Predict the product form at the cathode and anode in the electrolysis of molten mixture salt between calcium chloride and magnesium iodide. Okay, all right. So we have a molten mixture of salt. We have calcium chloride and magnesium iodide. Okay, so you have to separate this into cation and anions. And then you have to assign, okay, so the cations, the positive charge ion will be moving towards the negatively charged electrode, which is the cathode, okay, and then as for the anode, it is positively charged, okay, so the cation will be moving towards cathode and the anions will be moving towards anode. Okay, and we don't have water in this mixture of salt because it is molten. It's not solution. If it is a solution, that means we have water in it. That means we have to consider for the water as well to be discharged at the cathode or anode or both. Okay, all right, so we have to separate them into this category first, into cation and anions. And then from there, we have to choose which of these ions, okay, will be discharged at the cathode and which of these ion will be discharged at the anode. So how are we going to choose or select which ion that will be discharged? So we are going to be based on the E0 reduction values. Okay, all right. So we have learned that the positive, the value, okay, it will tend to be discharged at the cathode. Okay, so the cathode will discharge the positive value of E0 reduction. Okay, the more positive value, and then for the anode, it will prefer to discharge species that has less positive value or more negative value. Okay, just based on that. Okay, so let's look at the answer. Okay, so these two will be attracted to the anode. Okay, but however, iodide will be chosen to be oxidized. Because why? Because the value is more negative, because anode chose, okay, the one that we will selected ataupun discharge at the anode will be the one that has more negative E0 reduction ataupun less positive. Okay, all right, so in terms of the equation, okay, make sure that you know how to write the equation for oxidation, especially, yeah, for oxidation. Iodide, okay, undergoes oxidation, remove the electrons to become iodine. Okay, so iodine and other group 17 species ataupun molecules, they are all diatom. Okay, diatom. Okay, that means the neutral state ataupun the original form of them are in molecular element. Okay, so Cl minus will becoming Cl2. Okay, fluorine is rarely discharged. Bromine, okay, bromide ion, if it is oxidized, it will produce Br2. Okay, Br2, not Br. Okay, all right. So the product at the anode, we will observe the I2 solid, the iodine solid. Okay, all right. As for the cathode, So these two cation will be attracted to the cathode. However, the one that will be chosen or the one that will be selected will be the species having more positive E0 reduction. Okay, so in this case, we have these two. Which one is more positive? Which one has more positive value? This one. This is more positive than negative 2.76. Okay, all right. So it will be selected and will be discharged. So for the reduction equation, it is the same as the one that we have from SRP. Okay, from the reduction equation table last time. So it's the same. It's not a problem. The oxidation yang apa nama tu yang student tend to when the question asks for oxidation reaction, dia tend to bagi this equation which is in the form of reduction. This is reduction, okay guys. Okay, this is reduction. Bila kita nak oxidation, this is the equation that that the question wants if oxidation is requires. Okay, all right, so please take note on that. Half equation for so this is the reduction. So as you can see, the magnesium solid will be observed. Okay, we will obtain magnesium solid at the cathode. Okay, moving on. Secondly, next checkpoint, we have checkpoint 9. In the electrolysis of a diluted aqueous solution of sodium chloride solution, predict the product formed at each electrode. Okay, all right, just now we have molten salt. Now we have aqueous solution. And it is also specified here that it is a diluted solution. Okay, so the word aqueous here means we have water in the solution. Water is the solvent. Okay, and the term diluted is used here, shows that we have the amount of water in the solution is in large amount compared to the solute. Okay, so what we have water, amount of water is a lot considered compared to the solute. Okay, maksudnya dia cair lah, diluted. Of sodium chloride solution, predict the product formed at each electrode. Okay, so maksudnya ada water dekat situ. Okay, so basically the step is pretty much the same as what we had earlier. It's just that we have to include water. Okay, water will also be attracted at the anode and also at the cathode. Itu saja. And the way you choose the one that will be discharged is the same as what we had earlier. Sama saja, we are going to choose for cathode the one that has positive value, more positive value, for anode the one that has less positive value. Okay, it's just that they are the water saja. Okay, number 2, in the electrolysis of a mixture aqueous of solution of tin. Okay, so mixture aqueous solution, that means normal solution, we have water and the solute of tin to nitrate and copper to iodide solution. Predict the product formed at each electrode. So this is a mixture of solution of tin to nitrate and copper to iodide solution. Okay, so basically you have to list out all the ions for the cathode, all the ions for the anode, and include the water as well. Okay, and then you compare the value. Okay, let's look at the answer. Okay, this is for question 1. Okay, this is for sodium chloride solution, right? So sodium plus and Cl minus. Okay, all right, so don't forget water as well. Okay, all right, so this will be and the anode, we have Cl minus and water will be attracted to the anode. Okay, this is positively charged, negatively charged. Okay, so between these two, we are going to select the one that is more negative ataupun less positive. So this value is less positive than this value. Okay, so water will be discharged. Okay, water will be selected to undergo oxidation. Alright, so how do you prepare the half equation for oxidation of water? Okay, please take note that if water undergoes oxidation, it will produce oxygen. oxidation kan, so it produce oxidation. It produce oxygen. If water undergoes reduction, it will produce hydrogen gas, oxygen gas and hydrogen gas. Okay, so it depends on the reaction that the water undergoes. Dia bukan produce the same product. No, it depends on the type of reaction dia undergo. Okay, alright. So macam biasa, how do you write the equation for oxidation of water? Okay, so this is how you should be writing the equation. Okay, H2O. So the product will be oxygen, and then you balance out. So you have 4H plus and 4 electrons. So oxidation kan, the electron should be on the product side. So oxygen is the gas produced. So you will see there's bubble, okay, gas bubble produced at the anode. As for the cathode, okay, we will have these two sodium plus and water molecule will be attracted to the cathode. Tapi we are going to choose the one that is more positive. Okay, cathode kan more positive. So which one is more positive? H2O has more positive value. So H2O will be selected, okay, and it will discharge the H2. Okay, so this is the reduction equation for H2O. So it produces H2 gas, hydrogen gas. Okay, number 2 is also the same. Okay, it's just that now we have 3 ions, 3 species. Okay, 3 species that are attracted to anode. Okay, and then we are going to compare the value of the E0 reduction. Yeah, the value of the E0 reduction. So we are going to choose the one that is more negative. Okay, because we are talking about anode or oxidation. So the one that has more negative value is iodide. Okay, so iodide. So iodide will be chosen, and then iodide will undergo oxidation. So this is the equation of the oxidation of iodide. So this is the product. So iodine solid will be produced at the anode as the product. Okay, and at the cathode we have these 3 species. We are going to choose based on the E0 reduction that is more positive. So this is more positive. So copper 2 plus. Okay, so copper 2 plus will undergo reduction. Okay, guys, will undergo reduction. So it's actually the same as what we have up here. The equation is the same. Okay, so it will produce copper solid as the product. Okay, all right, that is checkpoint 9. Moving on to checkpoint 10. This is the last checkpoint. Predict the product form at the anode, only for the anode, for an aqueous solution of sodium fluoride with concentration diluted and very concentrated. Okay, all right, so we are only concerned on the product that will be produced at the anode ataupun the ion that will be discharged at the anode. Okay, not for the cathode. And then please take note that yes, this is aqueous solution, so we have to categorize into diluted and very concentrated. Diluted means we have more water. Okay, very concentrated means less water, more salt. Okay, more sodium fluoride. Okay, alright, so you have to explain why dekat sini. Okay, sama saja. Okay, dia punya method of approach to solve this problem. If it's diluted, okay, so kita punya competing species, competing yang maksudnya we have fluoride kan, so sodium plus and F minus. Okay, so this does not concern us because this will be going to the cathode. Kita nak anode saja, so fluoride will be going to the anode. And don't forget water as well. Okay, so we need these 2 value. Okay, so if it's diluted, we are going to compare in terms of value. Macam biasa, kena compare in terms of value. Okay, so kita akan choose anode akan more negative. Yes, ataupun less positive. Okay, so water will be discharged. water will be oxidized at the anode and produce O2. Okay, ni you kena transform kalau you are required to write the oxidation equation, you kena transform this into oxidation. Okay, this is in reduction form. So kalau oxidation, so how do you write? Like this one just now. This is one, okay? Bukan. This one. Okay, in the form of oxidation. Okay, terbalikkan. These two, sorry, all of this will be on the right hand side, right? On the right hand side. Okay, all right. So how about very concentrated, guys? How about if it's very concentrated? Remember the factors that we have learned earlier, okay? Before we know, before we determine which ions will be discharged, kan kita ada 3 factor kan? One of it will be concentration yang ada dalam table tu. Okay, alright. So we have to take into consideration as well. Okay, take into consideration the concentration. Okay, the concentration. Yeah, kalau dia very concentrated. Okay, walaupun in terms of value, yang concentration yang kita belajar last time, yang dalam table factor tu, ingat, this is a recap lah, macam tu Walaupun value katalah anode dia akan prefer more negative. Walaupun value dia more negative, tapi because of dia more concentrated, kita akan choose that ion yang has more positive value tu. Okay, itu kalau based on what we have learned lah so far. So maksudnya bukan sahaja dia punya E0 reduction, we have to consider in terms of concentration as well. But, dia ada but kat situ. Okay, but this is only applicable if the difference is not that far. Beza dia tak terlampau jauh. Okay, maksudnya kalau supposedly this one will be chosen kan. Tapi because of F minus is more concentrated, maksudnya we have a lot of F minus ions in the solution. Okay, so we are going to choose. This is like katalah dia dalam 1.5 macam tu kan. Dia 1.5. So we are going to choose F minus. Even though this is more negative. We choose this one if we choose this one because it is more concentrated. Okay, alright. Contoh, if this is 1.5, maksudnya perbezaan dia is not that far. But what happened to fluoride here? Okay, let me just erase this one first. What happened here is that the difference is too far. The difference is large. Okay, dia terlampau jauh sangat beza ni. This is 1 plus something. Kan, beza dia walaupun dia concentrated, even though it's very concentrated with F minus, but the E0 reduction is very, very far apart. Maksudnya terlampau jauh beza dia. So, fluoride will not be discharged. Okay, will still not be discharged. It will still discharge H2O. H2O will still be discharged at the anode because the difference is too far apart. Okay, the priority is still based on E0 reduction. Okay, we don't consider for the concentration. Okay, hope you get that. So the answer will be oxygen gas for diluted, and very concentrated is also oxygen gas. Okay, the two competing species is too large. All right. Yeah, that is all. Okay.